lost and down into the light now. Lost and down into the light now. Lost and down into the light now. Lost and down into the light now.
Hello students of Standard 11. Today we are going to discuss about the second chapter's second topic, that is relation. So what is a relation? We can say relation is the association between two sets. Now how we can associate, that is what we have done in the first exercise, that is cross product. So by doing the cross product, we are going to get the association between two sets, and then based on that only we are going to the next part, that is relation. So we can say like that, relation is the association of between two sets. In other way we can say that it is the subsets of cross product. So it is not necessary to be the whole elements of the cross product is required for a relation. Even its subsets also is enough. So based on that only we can define the what is called relation. So we can say that what is relation? It is the subset of cross product between two sets. Let it be A is a set is having m elements. Let it be A is having m elements, and B another set is having n elements. Then we know that A cross B will have, that is n of A cross B, we can say n of A cross B will have m into n elements. Naturally the subsets of A cross B will have how many subsets, that we know, that we discussed, number of subsets, that is number of subsets of A cross B is equal to 2 to the power m into n. Now all these subsets can be relations. Therefore, we can say number of relations from A to B. Number of relations from A to B will be 2 to the power m into n. If A is having m elements, B is having n elements, then the number of relations from A to B will be 2 to the power m into n. That is one result related to the number of results, number of relations from A to B. Okay, now this can be explained with the help of an example. Okay, relation. So I am going to explain with the help of an example. More clarity will get. Suppose A is a set is given 2, then 3, 4, let it be 5, and B is a set, let it be 3, 8, let it be 9, 3, 8, 9. Okay, A and B are specified, two non-empty sets we can say here, 3 elements, here also I have taken 3 elements, any number of elements possible. So if I go for the cross product, I will have 3 into 3, 9 elements. So I am not going for the whole cross product. I am going to select few elements in such a way that I am going to say a relation between the elements. I am telling you a relation like that is less than. I am telling you a relation is less than. Is less than is a relation I am telling from A to B. That usually we use the relation, the letter we use it as R. So it is given is less than means X component is less than Y component. So we need only such a type of elements. So therefore I can write the elements of this relation. You have to see all the elements one by one, and you select only those elements. Satisfying this condition is less than. Means X coordinate is less than Y component. X component, first component is less than second component. First of all, 3, comma 3. Is it 3 less than 3? You have to process in the mind. 3 less than 3? No. So that is not possible. What about 3, 8? 3 is less than 8, so it is possible. 3, 8. 3, 9. 3 is less than 9, that is also possible. With the 3 odd we are taken now with the 4. 4, 8, 4, 3. If you see 4, 3, is it 4 less than 3? It is not possible. 4 less than 8. Only we have to process the things in your mind and then write down. 4, 9, okay, 4 less than 9. Now with the 5, is it 5 less than 3? Not possible. 5 8, yes, 5 8 is possible, and 5 9 is possible. So these are the elements of this particular relation. So here I am telling the association between the elements. What is the association? Is less than. Is less than. So I have to select only those elements which satisfy this relationship. Okay, this is the relation I have written, is less than. So only we select only for few elements. Here altogether if you see 9 elements are there, but here you can see only 1, 2, 3, 4, 5, 6. Only 6 elements. So this is I have written the elements of this particular this relation. Whatever the relation is telling, its elements I have written. This way if you write the elements, this is known as roster form. This way if you write the elements, this is known as a roster form. This is known as a roster form. That is, instead you studied about the roster form. The same way here, we write the elements by putting the comma in between. That is a roster form. Then another thing, this can be written in set builder form also. Set builder form. Set builder form means we use all symbols. That is, we write set of all x, y such that here what was the relation I said? Is less than, x is less than y, and x belongs to the set A, y belongs to the set B. This way if I write, this is known as set builder form. This way if you write, it is known as set builder form. That is set builder form. So this relation can be written in set builder form, roster form, and one more way is there. This can be represented with the help of a diagram. With the help of a diagram, that is known as arrow diagram. What is that? So we draw. Okay, just to oval shape figure or circle, whatever it may be. Here A and B is given. A and B. A I am writing 3 4 5 3 4 5, and B is 3 8 9 3 8 9. Then I will mark down only these elements. 3 is connected with 8, 3 8, 3 9. Now with the 4 4 8, 4 9. Now with the 5 5 8, and 5 9. This way if you write the relation in the help of a diagram, this is known as arrow diagram. So the relation can be represented in 3 forms: roster form, set builder form, and arrow diagram. So this you have to know it. Now another thing you have to know about what is the domain of the relation. What is domain of a relation? What is domain? We write here domain of this relation. We can write domain of relation. We can write like this: D cap suffix R. Domain of the relation R. What is domain means? All the x component of that. X component here. Domain is 3 4 5. Domain of this relation we can say that's 3 4 5. Or if you see here also 3 4 5. Even here we have to find out the elements, or from the arrow diagram 3 4 5. That is the domain. So that is only domain. Now what is next term here? It becomes range. Range we will be writing it as range of the relation R. Range means set of all y components. Only y components here. Here you can see 8 9 8 9 8 9. So it is only 8 9. The range is 8 9. Here also if you see it, range is 8 9. This is not an element of that range. Okay. Only image part. This is not. These all known as images. We can say otherwise. This 8 and 9 is the range. So that is the range. Then another term here, one more term is there. What is the meaning of codomain? Codomain means here the relation is set from A to B. The relation is set from A to B. All the elements of B is known as codomain. All the elements means 3 8 9. 3 8 9 is the codomain. Alright, so you have to know these 3 terms. What is domain? Domain means of a relation means set of all x component. Range means set of all y component. But when it comes to codomain, if the relation is set from A to B, then the codomain is the set B. Set B. So these are things we need in this topic. After that, we can go to the exercise. So what is domain, range, codomain, and different way of representing roster form, set builder form, and arrow diagram. Alright, these are the things we need, and this is association between the elements of a set, that is known as the relation. See, here it was less than, sometimes is a factor. So different, if you come to the real life situation, if you make two groups, one group of gents and one group of what is called women, like the two sets if you make it. One set if you make it as of men, one another set if you make it as women. I can say a relation between husband is a husband. That means one particular person is the husband of one particular woman, okay, from this. So that way we can say it. So that is a real life situations. So only this is here you know it is the association between two sets. So now we will do a few questions from the exercise. That is the exercise 2.2. I think by now you have completed the chapter number 1 first 3 exercise and chapter number 2's first exercise. Now we will do chapter number 2 second exercise. The first question is, we will do first of all question number 1. It is given n of a is equal to 2, n of b is equal to 3. We need the number of relations from a to b. Number of relations from, in that first part, number of relations from a to b. Second part, b to a. Third part, a to a. Number of relations. Number of relations. I given a formula. Number of relations. Number of relations. I given a formula. Number of relations equal to 2 to the power m into n. Where m is the number of elements in A and n is the number of elements in B. So if you use this in the first case, the number of relations. In the first case, number of relations A to B. A is having 2 elements. B is having 3 elements. So it will be 2 to the power 2 into 3. That is 2 to the power 6. This is equal to 2 to the power 6. 2 to the power 6, we know how much it is? 64. It is coming to 64. This is the first part. Now when it comes to second part, B to A, number of relations from B to A is 2 to the power 3 into 2. This is coming again 2 to the power 6, that is equal to 64. That is the second part. Now the third part, number of relations from A to A. It is from A to A, so that is A is having 2 elements, second A is also having 2 elements, 2 to the power 2 into 2, that is 2 to the power 4. 2 to the power 4 it is 16. So this is the question number 1. All of you copy down, pause your video and then copy it. Another question number 7. Question number 7, here A is given. It said 2, 3, 4. B is given 4, 6, 9, 10. And the relation is specified R such that R in set builder form it is given xy such that x comma y belongs to A cross B such that x is a factor of y. So here the relation is specified is a factor. Is a factor is the relation. We have to write down R in roster form. We have to write the R in roster form. Is a factor. Its meaning is x is a factor of y. Only we have to select such type of elements. X will be from the first set. So only processing, do it in the mind and select the elements. 2. First of all, check it with the 2. 2, 4. Is it 2 is a factor of 4? You process it in the mind, then you will get 2 is a factor of 4. Yes, 2 is a factor of 4. Now what about 2, 6? 2 is a factor of 6, alright. What about 2, 9? 2 is not a factor of 9, that is not possible. 2 10 is possible. Now with the 3. 3 is it a factor of 4? No, so 3 is a factor of 6. 3 6 is possible. What about the 3 9? 3 9 is possible. 3 is a factor of 9. 3 10 is not possible with the 4. 4 4 4 is the factor of 4. 4 6 4 is not a factor of 6. 4 9 is not possible. 4 10 also not possible. These are the elements of this particular relation. Only select those elements. Processing do it in the mind. Just write the elements. Okay, this is question number 7. Now another question. Question number 10, second part. 10 second part. Here the question is write in roster form. Here also we are writing in roster form. R is given set of all x minus 2 comma x square such that x is a prime number less than 10. Is a prime number less than 10. X is a prime number less than 10. So you have to know first of all what is x stands for all prime numbers less than 10. That means the values of x will be 2, 3, 5, 7. This is the prime numbers less than 10. So with help of this we have to write down the elements. First element R. First element of R. In place of x you put 2. So 2 minus 2. That is 0, 2 square. Whatever you are going to put, I am going to put 2 first. 2 minus 2 is 0, 2 square is 4. With 2 I substituted, now I will go for 3. If I put 3 here, 3 minus 2 is 1 and 3 square is 9. Now with the 5 if I put 5 minus 2 it is 3, 5 square is 25. Now last 7 minus 2, 5 and 7 square is 49. So very simple calculation in one line we can do it. Just do the processing, the mind and required elements on the right. So this is question number 10. Pause your video and copy it. Ten is over. Now question number 18 we will do. Question number 18. Here R is given. R is equal to in set builder form again a comma b such that a and b both are natural numbers and a plus 3b is equal to 12. We have to list the elements of R and domain of R and range of R. First of all, we have to write down the elements of R. Is given A, B are natural numbers. So its meaning is A is natural number means we know 1, 2, 3, 4, etc. Even B is also natural numbers. 1, 2, 3, 4. Now we have to select the elements. We have to select the elements like ordered pair format. It should satisfy this relation. A plus 3b is equal to 12. This is the relation is given. A plus 3b is equal to 12. This relation, based on this, we have to write down the elements. So, first of all, I will take A is equal to 1. I will see it. 1 I am going to put here. In place of A, if I put 1, what will happen to B? If I put A here 1 plus 3b is equal to 12. So 3b is equal to 12 minus 1, 11. B is 11 by 3. It is not a natural number. B is equal is 11 by 3. It is not a natural number. So we cannot take this one. So 1 we cannot put. Now if you go for 2 if I put here. 2 if I put 2 plus 3b is equal to 12. 3b is equal to 10. B is equal to 10 by 3. This is also not a natural number. So you can do the processing in the mind now. If I go for 3 if I put 12 minus 3 is 9. 9 by 3 is 3. It's a natural number. So I can put 3 here. First element is 3. If I put 3 here, B is coming. B is also coming 3. So 3 is possible. Now I will go for 4. 3 I have taken. Now the next one is 4. I will see 4. If I put 12 minus 4, 8. 8 by 3 is not a natural number. That is not possible. Now after that we can see the next one is 5. 5 if I put 12 minus 5, 7. 7 by 3 is not a natural number. 5 not possible. 6. If you put 6, 12 minus 6. 12 minus 6 is 6. 6 by 3 is 2. That is a natural number. It is possible. Now 7 if I put 12 minus 7, 5 by 3 is not a natural number. Not possible. 8 if you put 12 minus 8. 4 by 3 is not a natural number. 8 is not possible. 9 if you put 12 minus 9. 3 by 3 is 1 natural number. So 9 if I put what is coming, it is 1. 9, 1 is possible. 10 if you put 12 minus 10 by 3 is not a natural number. 11 if you put 12 minus 11, 1 by 3 is not a natural number. 12 if you put 12 minus 12, 0, 0 by 3 is not a natural number. 0 by 3 is 0, is not a natural number. Now if you put anything more than that, 13 if you put, you can see negative number is coming, 13. 12 minus 13 is minus 1. Minus 1 by 3 is not a natural number. So that means only these are the possibilities we can stop here. So R is equal to only 3 elements are there, 3, 3, 6, 2, 9, 1. These are the elements of this particular relations. So only select the required elements and write it. This is the first part. And the second part of this relation is, domain of R. What is domain of this relation? Domain is all exponents, that is 3, 6, 9. Domain. And second part, the range of this relation, that is only the second elements, 3, 2, 1. That is 1, 2, 3 we can write it. This is the domain and this is the range of this particular relation. So this is question number 18. Only what are the elements is needed, select it. It's not necessary to show these things. All processing you can do it in the mind. Okay, now we will do next question number 23. Here A is given -2, -1, 0, 1, 2. List the ordered pairs satisfying the relation on A. Relation on A means it is from A to A. A to A means once again we have to copy down this A. -2, -1, 0, 1, 2. We need a relation on A means A to A. That is from A cross A we have to do it. Okay, we have to go for actually A cross A. In this we need only few elements satisfying the condition is greater than. With the only first part is greater than. The relation is given is greater than. Its meaning is x is greater than y. Means x component must be greater than the y component. So we need only such a type of elements. I am doing only first part, that is I have written R1. Only first part of this question I am doing it. X is greater than y. So first of all is the -2. -2, is it -2 is greater than -2? Not possible. So now -2, -1. So -2 is not greater than -1. So if you go with the -2, no elements are possible. Now with the -1, is it -1 greater than -2? Yes, -1 is greater than -2. That is possible. Now -1, not possible. Now no more possibility with the -1. Now with the 0. 0 greater than -2, that is correct. 0 greater than -1, that is not possible. 0 is not greater than 0, that is not possible. Now with 0, no possibility. With the 1. 1 is greater than -2. 1 is greater than -1. 1 is greater than 0. Now with the 2. 2 greater than -2. 2 is greater than -2. Okay, 2 is greater than -1. 2 is greater than 0, 2 is greater than 1. Yes, these are the elements of this particular relation. That is the first part of relation. Okay, this is question number 23, first part. Now we will do one more 26, question number 26. With that we will stop it, question number 26. Then 26. Find the linear relation between the components of this relation. Linear relation we have to find out between the components of this particular relation. Linear relation. They are asking find the linear relation. It's written linear relation. In that case, we know, we'll assume, let the relation be. Let the relation, I'm taking it as linear relation means I can say y is equal to mx plus c. Linear means line. So y is equal to mx plus c. Now I'll put the first component, I'll put as c. X is minus 1, y is minus 1. So minus 1 is equal to minus x plus c. Okay, minus 1 is equal to this minus m plus x. I am putting minus 1. Alright. So one I got. Now this one I put x is 0, y is 2. 2 is equal to x is 0. 0 plus c, so c is equal to 2. I got the value of c. C I will substitute here. C I will substitute here, then I will get the value of m. So c is 2. 2 I am substituting, so 2 which comes here. M is equal to 3 I am getting it. 2 minus 1 minus 2 minus 3, so it is plus 3. Therefore, the linear relation is y is equal to m is 3x plus c is 2. This is the linear relation. Okay, we'll stop here.
Lost and down, down.